Hi everyone, welcome back to your channel Wastewater Treatment in FE and PE civil exam sample question. So in this example we have like a wastewater treatment plant and its exiting flow, which is wastewater effluent, depleted to a downstream river, as you can see. And at the point, like what you can see here, it just enters the river. A river continue to move forward and with a new condition, which is a mixed flow. The concentration of 5-day BOD5 for the river and wastewater provided, and let's jump to see what the uh, uh, question asking us. So if we have an industrial wastewater effluent which is depleted to a downstream river, and it just at the intersection it's like the mixed flow move forward with a BOD5, which EPA, Environmental Protection Agency, allows to have like only a 5 milligram per liter of BOD5 in the mixed flow. We want to calculate the reduction in BOD5, a removal in the effluent wastewater in terms of percentile. So what the problem is asking, it just says there is a river downstream with a flow and the concentration of BOD5, as you can see, the same wastewater effluent with a flow of 10 mgd and BOD5 concentration of 100 milligram per liter. You can easily see the concentration of 5-day biological oxygen demand in the wastewater effluent is much higher in comparison to original river, which is 100 versus 2 milligram. And then it just intersect with the river, and EPA only allows to have like 5 milligram per liter of BOD5 in the mixed flow. So we have to reduce it anyhow with the screening and the wastewater processes to reduce 100 to a number in such a way that it, after mixing with the flow, it just gives us like 5 milligram. So and then we want to calculate that removal before entering the river. So again, our wastewater plant effluent depleted to a river, the specification of flow and BOD5 concentration for both is provided, and after intersection the river moves on with a mixed flow with the new condition. The flow definitely is the combination of the river and wastewater, but the BOD5 is just restrained by 5 by EPA to be only 5 milligram per liter. So first of all, we want to convert both flow to mgd, million gallon per day. So a 100 cubic feet per second. We do know that 1 feet cube is equal to 7.48 gallon. And if you don't know that, you can find it in the conversion table in your reference. And after that, it just simply converted to mgd, and it just gives us 100 CFS is equal to 64.63 million gallon per day. Now both a flow and BOD are in the same unit flow, both of them in mgd, and then we can easily jot down the equation: the river times the concentration of its BOD plus the wastewater in terms of mgd times its concentration. But be careful, this is the concentration just before entering the river, so it's not 100. It just, as we talk about it, it just reduces from 100 to a number which we are going to calculate it in such way that when it mixes with the original flow, it just gives us a 5 milligram per liter. So it just says river times its concentration plus the wastewater effluent flow times the final reduced BOD5 is equal to, definitely the mixed flow is the total of river and wastewater effluent. That's it's just a 10 mgd is added to 64.63, so it's 74 5.63 times the load EPA BOD concentration. So the only unknown is X, and you can easily calculate the amount of reduction. So you can easily see it BOD5 moves from the very exit of the wastewater, then goes through the screening and the other stuff to reach to 24.39 to get the 5 milligram after mixed with the river. So let's see how we can calculate that reduction. So the initial BOD in wastewater effluent was 100 and it just reaches to 24.39 over 100 times 100 and over the initial times the 100. It just gives us the reduction of BOD5 in wastewater effluent, which is 75.6%, and that gives us to be a choice D. Thank you. We'll solve more problem in FE and PE in terms of wastewater engineering. Thank you.